Okay, we're going to look at some graphs of some polynomial functions and talk about the end behavior and multiplicities and things like that. So first I'm going to start with some functions that you should already know. Y equals x, or x to the first power, a degree of 1, is just a straight line. X squared, we spent a couple of units on that, and that is going to be a parabola. It's a quadratic. So now I'm going to show you what happens when we have some of the others. So an x cubed, or a cubic function, when we graph it, looks something like this. When we have x to the fourth, it looks something like this. X to the fifth might look like this. And we keep going. So do you notice a pattern? For instance, this one is opposite. They're going in the opposite direction, the ends. This one, the ends are going in the opposite direction. This one, the ends are going in the opposite direction also. So what are those? What is the degree of those three functions? They're all odd functions. So what I'm hoping that you see clearly here is that if you have an odd degree function, the end behavior is going to be going in the opposite directions. On the other hand, if you have an even degree, so 2 is an even number, 4 is an even number, look at what's happening with those ends. They're both going in the same direction. They're both going up. Okay, so the thing I want you to get here is that if it's an odd degree, the ends are going opposite each other. And if it is an even degree, they're going in the same direction. So hopefully you remember what happens when we have a negative leading coefficient. That is a reflection over the x-axis, or it's flipped upside down. So instead of the line going upward, the line is going downward. Instead of the parabola opening up, the parabola is opening down, and it affects all these functions the same way. So a cubic will be going downward. To the fourth power will be going downward, and so on. Okay? Did it change the end behavior in a way? No, because all the ends for the odd are still going in the opposite direction. They've just flip-flopped the direction. And all of the evens are going in the same direction. It's just instead of pointing both upward, they're pointing both downward. Okay? So let's take a look at the ones I wrote on the side. We have x to the 1001. That is an odd. The degree is odd. So I know that that is going to have ends in the opposite direction. So something like that. And let's actually change this. Let's make that a negative. We can leave it a positive. It doesn't matter. When I'm looking at this one, I'm looking at x to the 1000 power. So this is an even degree, and it's a negative. So they're both going to be going in the same direction, but they're both going to be going downward. So something like that. All right. So in behavior, the way we write in behavior. Before, we used limit notation. And we could still use limit notation. So the limit as x goes to positive infinity, what is y doing? And the limit as x goes to negative infinity, what is y doing? Okay, so that's how we were writing it before. I will probably take it a little easier on you guys this time around. since we're not face-to-face with each other every day. And I'll probably just write it simpler like this. Either way, okay? But in behavior, we did that. That was in our first unit. So you can flip back in your notebooks to your first unit and you can see some more examples on that. We are going to talk about it now, though. So I want you to sketch the graph and state the degree and state the end behavior. I did not write that. And state end behavior. Okay. So the first thing I'm going to look at is that this is an even degree here. Okay. So the degree, which is 4, what do we call that? We call that a quartic trinomial, and that is an even degree. And that tells me that on my graph, both my ends are in the same direction. What I also notice is that I have a negative up front. So a negative tells me that they're all going in the downward direction. So if I have the ends going in the same direction, they're both going down because it's a negative. If it were a positive, they would both be going up. All right, so I know that the end behavior here says that they're both going in the same direction. They're both going down. So to sketch the graph, I can do something like that. So when I ask you to sketch the graph, I don't want exact points. I don't even care if you put a coordinate plane on there. I just want you to show me generally what that graph is going to look like. And so now that I've done that, I can talk about the end behavior a lot easier. So as x goes in the positive direction, y goes in a certain direction, and as x goes in the negative direction. So remember, that's what we're focusing on. We're looking as x goes to the right and x goes to the left. And then we see what is y doing. So as we go to the right, we are going down. And as we go to the left, we are also going down. So both of our ends are going down towards negative infinity. So I have sketched the graph, I have stated the degree is even, and I have written my end behavior there. Now let's take a look at the next one. So for this one, my degree is 5. This is a quintic binomial. It has 2 terms. The degree is 5, which is odd. And so this odd tells me the ends are going opposite each other. So I've got one pointing up and one pointing down. Then I can look in the front and I can see this is a positive. So the actual number 12 and 13 means nothing to me. But the positive tells me that it's going in the upward direction. So again, I've got a positive in front of my functions. So it's going up from left to right. I'm always looking from left to right. So it's going to look something like this. So again, it's going in the upward direction, and I got that because it's a positive leading coefficient. So here's my graph. Something like that. Nothing fancy. Doesn't have to be perfect. I'm not an artist. I don't expect you to be. So to look at my end behavior, as x goes to the right, what is y doing? And as x goes to the left, what is y doing? So to the right, y is going up to positive infinity. And to the left, y is going down to negative infinity. Okay. Now let's talk about multiplicities. All right, so we're just generally talking about multiplicities from a picture today, and then next part will be actually, or next unit actually, will be solving these algebraically, and then we'll be able to make a picture from there. So multiplicities are talking about your roots, zeros, remember all these terms, solutions, and x-intercepts. And it has to do with the degree of these roots or x-intercepts, but it also tells us how they're going to behave at the actual x-intercept. So if I look at something like this, and I look at where it crosses the x-axis at the x-intercept, it goes straight through. So when I'm talking about this, I'm going to use the words pass through or straight through. And this has a multiplicity of 1. Okay. The next thing you might see is where it curves, it hits the x-axis. This is the x-axis, by the way, and it bounces back up. So that is the term I usually use, when I'm talking about this one. This is a bounce, and a bounce has a multiplicity of 2, and it looks like a quadratic. This looks like a line. This looks like a quadratic, so a multiplicity of 2. We have the third possibility, which will look a little something like this. Kind of wiggles on the x-axis. So it goes up or it goes downward, and it kind of wiggles at the x-intercept and then keeps on going in the direction that it was going. So this I call a wiggle when I'm talking about it. And it is a multiplicity of 3. Okay, so when you see this, you know you have a multiplicity of 2. This is a multiplicity of 3. All right, so let's look at some examples. We can tell a lot of things from our graphs. First of all, I'm going to look at my x-intercepts. So this is an x-intercept at -3, and it passes right through, which tells me that it has a multiplicity of 1. Then I have this x-intercept here at 4, and it bounces up at the 4, so that is a multiplicity of 2. Okay, I can also tell what the degree of this is by my multiplicities. If I have a multiplicity of 1 and a multiplicity of 2, I add those together and I get 3, which is an odd number. And if I look at my picture, my graph, I see that the ends are going in opposite directions, which is the way an odd function behaves. It has opposite directions for my end behavior. I can also tell my leading coefficient, and I can tell that because it starts down low. So it starts down low and it ends up high. So I know that it's going in the positive direction. And then lastly, I can tell my end behavior. So as x goes to positive infinity or right, so as x goes in the right direction, y is going up towards positive infinity. And as x goes to negative infinity, y is going down towards negative infinity. Okay, let's look at another one. So I have this x-intercept here at -2, and that is a wiggle, so it goes up and it kind of lingers for a little bit. So that tells me there's a multiplicity of 3 here. Then I have another x-intercept here at 5, and that's another one of the bounces. So that's a multiplicity of 2. So looking at my degree, I have 3 and 2 multiplicities, which gives me a multiplicity of 5. Again, that's odd, and my graph supports that because my ends are going in the opposite direction. My leading coefficient, again, it starts down low and it ends up high, so that's a positive leading coefficient. And then my end behavior, so again, as x goes to the right, y is going up. So the end behavior, both of these are positive odd functions. The end behavior is also going to be the same. As x goes to negative infinity, y is going in the downward direction to negative infinity. And one more example. Oh. All right, so take a look at this one. I have an x-intercept at -4. It's a pass-through, so that's a multiplicity of 1. I have another x-intercept at 1. That is a bounce, so it's a multiplicity of 2. And then I have another x-intercept at 5. That is another pass-through, so that's a multiplicity of 1 also. So when we're trying to determine the degree of this function, I have 1 and 2 and 1. That together is 4, which is an even number. And my picture supports that because both of my ends are going in the same direction, which is the way an even function behaves. The leading coefficient for this one is going to be negative because this function is opening in the downward direction. So that's a negative. That symbolizes that we have a negative leading coefficient. And lastly, we'll talk about our end behavior. So as x goes to positive infinity or to the right, y is going down towards negative infinity. And as x goes to negative infinity or to the left, y goes down again in the negative infinity direction. So both of our ends are going in the same direction, which means our end behavior should be the same.